From giant pipelines to massive cargo, discover how railways conquer scale, where steel tracks turn impossible logistics into powerful, seamless journeys. Steel Mains is Australia's leading manufacturer of water pipeline systems, with more than 125 years of proven expertise in delivering major water infrastructure projects. As water becomes the nation's most critical resource, the company plays a vital role in ensuring projects are completed on time and within budget. Steel Mains has successfully supplied and installed pipelines for numerous high-profile developments. These include the Southeast Queensland Water Grid, involving 334 kilometers of Syntecote steel pipes, and the Sunwater Burdekin to Moranbah pipeline, where 172 kilometers of steel pipes were delivered at an impressive rate of over 5.5 kilometers per week. Other landmark projects include the Goldfields Superpipe, the Sugarloaf Pipeline, the Victorian Desalination Project, and the Woolleybee Creek to Glebe Weir Pipeline. Central to this success is the advanced Syntecote corrosion protection system, capable of lasting over 100 years. With strong local manufacturing, logistics support, and world-class training, Steel Mains continues to set benchmarks in Australia's water infrastructure sector. The Glebe Weir Steel Pipeline project in Queensland delivers 36,500 megalitres of treated coal seam gas water annually. Steel Mains manufactured and supplied 120 kilometers of large-diameter pipes, ranging from 940 to 400 millimeters, ensuring fast installation, durability, and flexibility for irrigation and industrial use. The Australia Pacific LNG pipeline represents one of the nation's largest coal seam gas to liquefied natural gas projects. Central to its scope was the construction and commissioning of a 530 kilometers main gas transmission pipeline, supported by 150 kilometers of smaller pipelines. These pipelines transport gas from the Surat and Bowen basins to Curtis Island, Gladstone, where it is processed for export. The main 1,050 mm high-grade steel line delivers 560 terajoules of gas daily, while smaller pipelines range from 18 to 36 inches in diameter. Awarded to the McConnell-Dowell/CCC joint venture, the contract covered full engineering, procurement, and construction. Pipeline construction began with unloading and transporting 270,000 tons of 18-meter pipes from Gladstone Port to laydown yards. A 40-meter right-of-way was prepared, enabling progress of 1.5 kilometers per day. Automatic welding lines completed up to 150 welds daily, followed by ultrasonic testing, blasting, and epoxy coating. After trenching 2.25 meters deep, crews lowered 1 to 1.2 kilometers pipe strings, padded trenches, and backfilled. Sections up to 30 kilometers were hydrostatically tested, then reinstated. Facilities included valve stations, launcher, receiver, and scraper sites. Murphy Pipe & Civil has established itself as a leader in the Australian pipeline sector by introducing innovative equipment and pipeline solutions across the oil, gas, water, and mining industries. Central to this achievement is the company's adoption of HDPE plow technology, pioneered through the use of the German-built Fexberry spider plow. This groundbreaking system has transformed pipeline construction by combining productivity, workplace safety, and environmental responsibility in one advanced solution. The spider plow is recognized as the most efficient pipe-laying system in the world. It is fast, cost-effective, requires smaller crews, and causes minimal ground disturbance. Unlike traditional trenching methods, the plow cuts a narrow pipe bed up to 2.8 meters deep, closes it almost immediately, and avoids mixing subsoil with topsoil. This ensures higher safety standards and lower environmental impact. The system installs HDPE pipes, fiber optic and high-voltage cables, as well as steel pipes, all in a single pass, handling pipe sizes up to 630 millimeters. It can also install tracer wires or markers simultaneously, enhancing operational flexibility. The Spider Plow's independent leg system allows it to operate on hillsides, valleys, and undulating ground, while a special skid system enables it to cross soft or marshy areas. Its three major advantages are clear: improved safety with no open trenches, reduced environmental footprint with a 10-meter easement, and remarkable speed with capacity to install up to 10 kilometers of HDPE pipeline per day. Murphy Pipe and Civil enhances this technology with a modern fleet of fast fusion machines for pipe preparation and jointing. Backed by strong collaboration with German manufacturers, the company continues to refine the system, ensuring versatility and global application potential. The result is a class-leading pipeline installation solution that delivers measurable benefits in safety, environment, time, and cost. The UA Local 342 pipeline bore process represents a highly specialized underground construction method designed to install pipelines with minimal surface disruption. In this project, crews prepare the site by carefully aligning equipment and setting up the bore rig at the entry point. The process begins with the drilling of a pilot hole, which guides the path of the pipeline beneath the ground. This step requires precise control and constant monitoring to ensure accuracy, particularly when navigating beneath existing infrastructure or natural obstacles. As the bore advances, specialized tools and drilling fluids stabilize the hole, prevent collapse, and reduce friction. Once the pilot hole reaches the designated exit point, the crew enlarges the bore to the required diameter using reaming tools. This enlargement stage allows the pipeline to be pulled smoothly into position. The actual pulling of the pipeline is a critical phase, where heavy-duty machinery and skilled operators work together to ensure the pipe enters the ground without damage. This trenchless technique is not only efficient, but also environmentally considerate, reducing the need for open excavation. UA Local 342's expertise ensures that the pipeline bore process is executed safely, effectively, and to the highest industry standards. The Shangu pipeline automatic welding machine is a key technology applied in the ground frame construction of the BNSF North area, covering the section from G02 to N06 for the external pipeline project. This advanced machine is designed to ensure high-quality, precise, and efficient welding operations required for large-scale pipeline installation. By utilizing automated welding systems, the project significantly reduces manual workload while improving consistency and safety in the welding process. The machine is capable of handling continuous operations under challenging outdoor conditions, maintaining stability and accuracy across long pipeline sections. Its application in this project not only accelerates construction progress, but also ensures strong, durable joints that meet strict engineering standards. As a result, the Shangu automatic welding machine demonstrates its vital role in delivering reliable and modern solutions for external pipeline projects. The XINGUA302 automatic welding machine is an advanced solution designed for pipeline maintenance and repair, widely applied in long-distance oil and gas pipelines, refining pipelines, and water networks in petrochemical and construction industries. This versatile equipment supports multiple welding processes, including MIG, TIG, and SUW, making it suitable for both new pipeline projects and repair operations. The machine is configured with a welding head, LCD portable panel, digital welding power source, control cables, flexible magnet track, and an integrated workstation. Its intuitive computer control system allows precise adjustment of welding parameters, ensuring easy operation while minimizing accident risks. A key advantage of the A302 is its ability to deliver consistent welding quality, unaffected by operator conditions or external environments. Equipped with a full-position welding parameter management system and high-precision 3-axis acceleration sensors, it adjusts parameters in real time. Furthermore, its built-in expert database enables quick adaptation to various pipe diameters, materials, and processes, ensuring standardized, reliable, and high-quality welding performance. The BNSF Vestas wind turbine support train was captured traveling northbound on the joint line in Monument, Colorado on February 18th. This specialized train is designed to transport critical wind turbine components for Vestas, supporting the renewable energy sector. Its movement highlights the efficiency of rail logistics in handling oversized cargo and delivering sustainable infrastructure. The sight of the long, consist, carrying massive turbine parts demonstrates BNSF's role in advancing clean energy projects nationwide. Balkan Rail Trans provides professional international railway transportation services, ensuring reliable and efficient logistics solutions for global trade. With extensive expertise in rail freight, the company manages the safe and timely movement of goods across borders, connecting industries to key markets. Their operations focus on cost-effectiveness, sustainability, and punctual delivery, making rail transport a strong alternative to road and sea shipping. By combining advanced logistics planning with modern railway infrastructure, Balkan Rail Trans supports international supply chains while maintaining high standards of professionalism and customer satisfaction. The FedEx Freight Expansion Project includes the installation of cast-in-place pipes to support efficient drainage and underground utility systems. This method ensures durability, adaptability, and cost-effectiveness for large-scale construction works. Workers construct formwork, place reinforcement, and pour concrete directly on site, allowing precise alignment and integration with surrounding structures. Once cured, the pipes achieve high structural strength and long-term reliability. Meeting heavy load requirements of freight facilities, the use of cast-in-place pipes enhances infrastructure stability and supports FedEx's operational growth. Pipeline installation in the United States plays a vital role in supporting the nation's energy, water, and industrial infrastructure. The process typically begins with route planning and environmental assessment to ensure minimal impact on surrounding communities and ecosystems. After permits are secured, construction teams clear and grade the right-of-way, preparing a stable foundation for the pipe. High-quality steel or polyethylene pipes are delivered to the site, inspected, and aligned along the trench. Specialized machinery then lowers the sections into place, where welding crews join them with advanced techniques to ensure strength and leak-proof performance. Non-destructive testing, such as ultrasonic inspection, is used to verify weld integrity. Once complete, the trench is carefully backfilled and the land is restored as close as possible to its original condition. In many projects, horizontal directional drilling is employed to cross rivers, roads, or urban areas without disruption. Safety and regulatory compliance are prioritized at every stage, with strict monitoring by federal and state agencies. Overall, pipeline installation in the U.S. combines engineering expertise, modern technology, and environmental stewardship to deliver reliable systems that transport oil, gas, water, and other resources essential to daily life and economic growth. The installation of oil pipelines in the United States represents a critical part of the country's energy infrastructure, ensuring the safe and efficient transportation of crude oil and refined petroleum products from production fields to refineries and distribution centers. Pipeline construction is carried out through a highly organized process that combines engineering precision, advanced technology, and strict safety standards. The first stage involves detailed planning and route selection, where engineers consider environmental impacts, land use, and regulatory approvals. Surveying and mapping ensure the pipeline follows the most efficient and least disruptive path. Once the route is approved, clearing and grading of the construction corridor begins, creating access for equipment and workers. Trenching is then performed using specialized machines to dig a continuous channel. High-strength steel pipes are transported to the site, inspected, coated for corrosion protection, and carefully laid into the trench. Automatic welding machines and skilled technicians join pipe sections together, while non-destructive testing methods verify the quality and durability of each weld. After welding, protective coatings are applied to joints to guarantee long-term integrity. Before backfilling, hydrostatic testing is carried out, where water is pumped into the pipeline under high pressure to ensure there are no leaks or weaknesses. Once tests are passed, the trench is refilled, and the surface is restored to its original condition, including replanting vegetation to minimize environmental impact. Finally, the completed pipeline is connected to pumping stations and monitoring systems that regulate flow and ensure operational safety. Modern pipelines are equipped with advanced sensors and control centers that allow real-time monitoring to detect pressure changes or potential leaks. Overall, oil pipeline installation in the U.S. is a complex yet essential process, balancing energy demands with safety, efficiency, and environmental responsibility. The installation of the Rody R8 pulling system horizontally is demonstrated through a pipe bursting operation. In this procedure, the R8 unit is set up inside the basement, and instead of being positioned vertically, it is operated horizontally to showcase its adaptability. This approach is particularly useful when working near a foundation wall, concrete surface, or other confined spaces where vertical pulling is not practical. The process begins with positioning the Rody R8 in line with the existing pipe path. From the basement, the pulling head is guided into the ground and directed toward the pit where the bursting and replacement will occur. The machine is carefully aligned to ensure a straight pulling path, reducing friction and minimizing potential obstructions. Operators then activate the pulling sequence, allowing the R8 to drive the bursting head and replacement pipe smoothly through the soil. During operation, the system maintains steady tension to break apart the old pipe, while simultaneously installing the new line. The horizontal pulling method proves advantageous when utilities, structural walls, or septic tanks limit vertical access. In such scenarios, the horizontal setup ensures efficiency and safety while avoiding unnecessary excavation or structural disturbance. As the pulling continues, the machine demonstrates consistent power and control, ensuring that the replacement pipe is properly seated. Once the full length of pipe is installed, the R8 is withdrawn and the pit is secured. Overall, running the Rody R8 horizontally showcases its versatility in tight or obstructed workspaces. This method is highly effective, offering contractors a reliable solution for pipe replacement projects where traditional vertical pulling is not feasible. The replacement process begins with preparation. A small access trench is dug at the start and end points of the pipeline segment. The new pipe is prepared and connected to the specialized bursting head. A steel cable is then attached to the head to enable pulling through the line. The replacement of underground sewer pipes has traditionally involved extensive excavation, which is both disruptive and costly. However, modern trenchless technology has transformed this process, enabling contractors to replace old pipelines with minimal digging. One of the most efficient solutions in this field is the R8 pipe bursting system by Rody Inc. Compact yet powerful, the R8 offers a reliable method for replacing deteriorated sewer lines without the need for large trenches. The R8 pipe bursting system is a 30-ton hydraulic machine designed specifically for trenchless applications. Unlike conventional replacement methods, this system employs a specialized bursting head that is pulled through the existing pipe. As it advances, the head fractures the old pipe material, whether cast iron, plastic, or even concrete. Simultaneously, the surrounding soil is expanded to create enough space for the new pipe. This innovative process allows seamless installation of new pipelines ranging from 1 to 8 inches in diameter. One of the greatest advantages of the R8 system is its compact design. Its small footprint enables operators to work in confined locations, such as basements, crawl spaces, or manholes, where larger equipment cannot be used. This flexibility makes the R8 particularly useful for urban projects, where space is limited and surface disruption must be minimized. Next, the setup phase takes place. The cable is carefully threaded through the old pipe using a duck rod, ensuring that it runs the entire length of the existing sewer line. The R8 machine is then positioned at the pulling end, and a pressure plate is placed against the ground surface to stabilize the unit and prevent it from being drawn underground during operation. Once setup is complete, the bursting stage begins. The hydraulic power pack is engaged, and the machine starts pulling the cable, which in turn draws the bursting head forward through the old pipe. As the head moves, its conical shape fractures the surrounding pipe material into small fragments. At the same time, the soil is displaced and compacted, forming a clear passage for the replacement pipe. Finally, the replacement stage occurs. Attached directly behind the bursting head, the new product pipe is pulled smoothly into the expanded pathway. By the time the head reaches the end of the line, the new pipe is already fully in place, securely replacing the old infrastructure without the need for open trench excavation. The VIHY Masterflex concrete pipe making machine plays a central role in the modern production of small bore quality pipes. Specifically engineered for manufacturing non-reinforced concrete pipes, this machine is also capable of producing branch pipes and manholes, making it highly versatile for urban drainage and sewerage projects. One of its main advantages lies in its compact design, which allows installation in factories with limited floor space while still ensuring high productivity. The Masterflex is particularly valued for its ability to achieve high-speed production, enabling manufacturers to meet the growing demand for infrastructure components efficiently. Hachin. The machine operates with a synchronous core vibration system, which maximizes compaction while minimizing cement usage. This ensures that the finished pipes maintain exceptional strength and durability, even though less raw material is consumed. Furthermore, an automatic concrete feeding system ensures that the concrete mix is distributed evenly into the molds, resulting in pipes with consistent quality and structural integrity. In addition to its technical capabilities, the Masterflex offers significant operational efficiency. It can run in a largely automated mode, allowing operators to focus on other production-related tasks. This not only reduces labor requirements, but also increases overall output, making it a cost-effective solution for concrete product manufacturers. The production range of the Masterflex is another strong point. It can manufacture pipes with diameters ranging from as small as 100 millimeters to as large as 600 millimeters. This makes it an excellent choice for producing both small drainage pipes and medium-sized conduits, covering a broad spectrum of project requirements. Overall, the machine demonstrates a combination of precision, efficiency, and versatility, establishing itself as a reliable machine for producing high-quality small-bore concrete pipes in today's construction industry.